Okay, I'm going to talk now about the confusion between what the young and the old Einstein was saying. And this is part of the confusion which exists in modern physics, because there seems to be conflict between what the young Einstein was saying and what the old Einstein was saying, and it gets very confusing. So I'm going to be referring to what a Professor John D. Norton is saying. I'll show you his bio. This is John D. Norton. He's a Director, Centre for Philosophy of Science and Distinguished Professor, Department of History and Philosophy of Science at the University of Pittsburgh. And he's going to be referring to the article by him called The Young and the Old Einstein. He's written quite a lot about Einstein, and so it's quite a lot to go through. So I'm just going to concentrate this on the moment on the young and the old Einstein, what he's written about, and show some of the confusion that Einstein has given us. So here we go. This is the article by him. He says, maybe I can make it bigger. Sadly, it's not going to be any more videos, it's just talking through a slide of here. Right. The Einstein of popular thought is the young Einstein. This is the intellectual rebel of 1905 who in 1 year laid out the special theory of relativity and E equals mc squared, postulated the light quantum, and used Brownian motion to make the case for the reality of atoms. And these achievements were made prior to Einstein holding an academic position, and I think that's all well known. He was then still a patent examiner in the Bern Patent Office. The years that followed brought Einstein a succession of ever more prestigious academic appointments, and in the mid-1910s he delivered his masterpiece, The General Theory of Relativity. That's fairly well known. Here's the young Einstein. This is John Norton's views on these things. In all of this, there was a real sense that Einstein was ahead of his peers, leading the way. The special theory of relativity was absorbed into the mainstream of physics fairly quickly. The general theory of relativity was not quite so readily accommodated. This was in part due to its burdensome mathematical demands of the theory, at least relative to the standards of mathematical expertise then found among physicists. But the tide was flowing with Einstein when the eclipse expeditions of 1910 vindicated Einstein's theory, and he became a popular hero. Critics risked being seen as unimaginative reactionaries. So he suddenly shot to big fame in 1910, and it's sort of like the critics weren't getting their fair hearing really. And so if I can go to my videos, next. So if I go, no, it must have been the last one. Right. That one, that's it. This is that one. So we've still got critics of Einstein's relativity today, as highlighted in my video. I look at Professor Ryden's talk on Einstein being wrong, and Professor Ryden looked at general relativity and found it to be a nonsense. And this is in modern times, still 100 years or so after Einstein's general theory of relativity. It still doesn't really make sense. We've still got critics of it. So when it comes to this, critics were being unfairly treated, in 1919 when Einstein came up with his theory, and still today we have critics who are criticising Einstein's theory. So things haven't really changed on that front. Really, Einstein's theory should have been looked at more critically in that time and had a big debate upon it to decide what they were going to do. But when we look at the history, it was sort of like really messed up. It was sort of embroidered into politics and things, and people hating Einstein for other reasons. It was difficult to look at just the physics. Right. I don't really want to go into quantum physics, but it does touch on it a bit. If we go, Einstein's work on the light quantum did not fare so well. It was regarded many as an odd aberration from an otherwise brilliant mind. Even in the early 1920s, it was doubted by Niels Bohr, who had a decade before developed the first quantum model of the atom. By the end of the 1920s, however, another Einstein began to emerge as the quantum theory enjoyed success after success. Einstein found himself unconvinced. He took on the role of critic, that is, criticising quantum mechanics, complaining that the new quantum theory, for all its virtues, could not be the final theory. This was Einstein's new place in the physics community for his final quarter century, ending with his death in 1955. So from the 1920s to the 1955, he was criticising quantum theory. He remained a revered figure, but he became increasingly isolated and marginalised as he laboured on his alternative theories with the help of a few assistants. In the years after his death, it became clear that Einstein's objection to quantum theory failed, but not, I believe, for the reasons articulated by his arch antagonist Niels Bohr. And I've got a wiki link, I think, on this. Yeah, wiki link gives a rough summary of this. It was the Bohr-Einstein debates where they were given a series of public disputes about quantum mechanics between Einstein and Niels Bohr. So it's fairly well known, and I've lost it now. Oh, back to here. So what I think is Einstein was liking his general relativity too much, and he was not liking quantum physics. And Norton, who's writing this, is voicing his opinion about this sort of thing. But I'm not really wanting to go into that. Here's pictures of Einstein. The old Einstein is a recalcitrant Einstein, unwilling to swim the new quantum tide that flooded over physics. So he's not wanting to go with the new quantum physics. He wants to stick with his relativity. We should not judge that harshly. No thinker can ever think purely new thoughts. We all sit at the junction of the old and the new. Einstein was one of the first of the new physicists of the 20th century. His discoveries and methods exercised a profound defining influence on the development of 20th century physics. And my point of view on that, he's had too much influence. It's just far too much influence from Einstein, and so you've got too many of his mistakes now coming into modern physics. However, there is also a strong sense in which he is one of the last of the 19th century physicists. Perhaps he was the greatest of them. So I think what they're trying to refer to here, because he's rejecting quantum physics, that he's still sticking in the fast with 19th century physics. But actually he's really changed things from 19th century physics with his relativity. So the themes of 19th century physics is what we're going on to now. To see why this is not such an unreasonable assessment, we should review the major discoveries and themes of the 19th century, and then see how they came to be realised and even fulfilled in Einstein's research. We shall look at these three categories: Einstein's science, his methods and his outlook. So Professor Norton thinks Einstein is a continuation of 19th century physics, and he thinks that's his view of it. I don't really take that view. I think he's made a lot of mistakes on top of what was 19th century physics. So this is contrasting what's happening. This side here is 19th century, and this side is what Einstein's doing. So in the 19th century we had electrodynamics, and from Einstein we have special relativity. So in the 19th century we're saying the great discovery in physics of the 19th century was Maxwell's electrodynamics and its development by later physicists including Lorentz. So Einstein's contribution to that is special relativity. Einstein took special note of the kinematic effects mixed in with the electrodynamic effects of Lorentz's theory. So Lorentz's theory on electrodynamics, and Einstein is supposed to say, taking note of that. But what we really got, if we go back to the 1905 paper on Einstein, I think I've still got it here. This is the paper on the electrodynamics of moving bodies by Einstein in 1905. He's not referencing, he's not at the end, we're not seeing on the footnotes, these are editor's notes, and these are footnotes added by the translator. What we have here is from Einstein, and he's given us no references as to what he's working from. So if you're going by his 1905 paper, you don't really know whether he is working from Lorentz's theory or not. I think he mentions Lorentz transformations, but let's go back up. Find it. Find Lorentz. Yeah. So he's mentioned Lorentzian electrodynamics, but he's not really saying whether he's obeying it or not. He's not given references to that. So we're going back. This is Einstein now. He saw that they could be separated out as a novel theory of space and time, independent of the electrodynamics. And I don't really think Einstein's clear in doing that, if you read his 1905 paper. So this is sort of what Professor Norton is thinking. The result was the special theory of relativity. Its central equations were the same transformation equations that Lorentz had employed in his development of electrodynamics. So you've got Lorentz's theory of based on Maxwell's electrodynamics, and then suddenly you've got Einstein's special relativity, so say from Lorentz. So what's going on here? This link between Lorentz and Einstein is very unclear. So that's one of the sources of major confusion. What's the connection between Lorentz and Einstein? Professor Norton is not telling us. In the 19th century, go back, Newton's physics had been very successful in recovering the properties of things like apples and planets that move at ordinary speeds much less than that of light. So Newton's physics is good for gravity. This is in the 19th century. 19th century electrodynamics now succeeded in probing the properties of things moving close to the speed of light, charges accelerated at high speeds and light itself. Right, and Einstein is commonly understood as repudiating 19th century electrodynamics in his rejections of its ether. And that's a major problem. Why should he reject ether? If you go back to Lorentz has ether. so Einstein's rejecting it. So it's very confusing. Lorentz and Maxwell, suddenly Einstein's doing something, rejecting ether, what's going on? And this is not being covered very well by Professor Norton. That assessment is altogether too narrow. In extracting the kinematics as an independent theory, Einstein was harvesting one of the greatest fruits of the 19th century theory. The ether was merely superfluous foliage that needed to be trimmed away during the harvest. So this is Norton thinking you can just throw away the ether, and that doesn't really make any sense. Why? How can Lorentz have it and how can Einstein not have it? If we go to the heretic site, the physics heretic on his site, he makes a list of the greatest lies in physics, and I've got a long way. Continue reading. Let's have a look. No, go back. Previous. Lie number 10. 9, 8, 7, 6, 3, 2, 1. And his greatest lie in physics, number 1, he says, that lie is there's no ether. And he says, of all the lies told by physicists, none has been so damaging a lie than saying there is no ether. Since the beginning of scientific endeavour, scientists had always assumed that there was an ether in space, a medium for the transmission of light and forces. Unfortunately, ill-conceived experiments such as the one by Michelson and Morley cast doubt on the ether models of that time. That doubt was to take hold at the very time when Max Planck came up with a more proper explanation of ether, beginning the modern era of ether, now referred to as a vacuum fluctuations and 0-point energy. I don't know if it was Max Planck who actually came up with that. That's more sort of coming out from what Heisenberg is talking about. So you've got this quantum fluctuation thing and 0-point energy, which is sort of like an ether. So even Einstein jumped in before he became a fully fledged ether denier by co-inventing. Well, this is what the heretic's saying. Basically, saying there's no ether is a very damaging thing, has been a very damaging thing on physics, and Professor Norton is just trying to say it's trimming away things, and it seems to be the ether they've trimmed it away and they're trying to bring it back again with things like 0-point energy. So this is, don't think that is too relevant. It's sort of like length, moving systems shrink and time slows and things. This is from Lorentz. So on the Einstein, the special theory of relativity is the natural completion of 19th century electrodynamic theory, and I don't think so. They're not saying how it connects to Lorentz theory, and this rejection of the ether is very arbitrary. 19th century. So got 19th century and thermo and statistical physics, and you've got Einstein, the reality of atoms. But I'm not really criticising that too much, because I just want to stick to criticising the relativity. So this is about the methods. 19th century, then you've got Einstein. And he's talking about quantum, so it's not too relevant to what I'm criticising. Next this is coming on to the relativity again. You've got 19th century with geometry, and you've got Einstein with his general relativity. If the 20th century was the century of novel physics, the 19th century was the century of novel mathematics. Geometry had always been central to science, but it was languishing. Newton's mathematical techniques in his Pacifica of 1687 would have been immediately intelligible to Euclid himself. So Newton is using Euclidean geometry. So the changes in the 19th century, there was an explosion of new ideas and methods. One of the foremost achievements of the century was a new conception of geometry. It included the idea of non-Euclidean geometries and their accommodation to yet more sophisticated geometries, notably projective geometry. And it goes on to say about Felix Klein's Erlangen program unified the many new geometries found in this century by means of another mathematical advance of that century, group theory. So that's the maths which was sort of developed in the 19th century and sort of what Einstein then used in general relativity. Einstein's general theory of relativity provided a qualitatively new way to think about gravity. That is Einstein's signature novelty. I think not quite other people were working on that maths from the 19th century and trying to apply it to physics. From a physical point of view, Einstein's theory was a bold departure. From a mathematical perspective, however, it simply applied 19th century mathematical techniques to a new and highly interesting application, i.e. just applying 19th century maths to physics. Where Newton had employed Euclid's mathematics to display his account of gravity, Einstein employed the 19th century advances in geometry as the basis of his new theory. The explicit framework was provided by Ricci and Levi-Civitati's absolute differential calculus, now called tensor calculus. Einstein's mathematician friend Marcel Grossmann found Ricci and Levi-Civitati's review article of 1901 on the calculus and drew it to Einstein's attention. It provided the framework he needed for his new theory, the theory of general relativity. So, carries on with that. And we've got down here about the unification in the 19th century, and then it's Einstein's attempt at unified field theory, and it's supposed to be that he had trouble trying to combine gravity and electromagnetism into a unified field theory. We go down now to the main thing. It's the ether. In the 19th century, ether, the grounding of 19th century electromagnetic theory was the ether. Electric and magnetic fields were not distinct processes but were merely manifestations of different states of an all-pervading medium, the ether. And what does Einstein do? Above, he's above in 1905, he's discarded ether. That's a long way up. Discarding ether. The ether was merely superfluous foliage and needed to be trimmed away during the harvest, so he's discarding it there. So we go down to what he's doing with ether now, and he's got ether's metrical ether. Einstein famously did away with the ether, or more precisely, he announced its superfluous and railed against the preferred state of rest attributed to it. However, in his general theory of relativity and his unified field theories, attempts at unified field theories, Einstein retained an analogous background medium. It was not the ether of the 19th century, rather it was a kind of geometrized version of it. The geometry of space-time provided a substratum whose properties would be manifested as gravity and electromagnetism. Indeed, as a concession to Lorentz for a short time around 1920, Einstein talked of the metrical field, the carrier of geometrical properties, as an ether. So this is Professor Norton. He's not really tying in how this sort of new ether, metrical field, metrical ether, is connected to the 19th century version of an ether. And if we go back up here, a long way back, he was saying that on electrodynamics we had Lorentz's theory, and Einstein was connecting on to Lorentz's theory, but Lorentz's theory had an ether, and so why is he suddenly discarding it? So how is this metrical ether which he's introducing, how is it supposed to be connected to Lorentz's ether? Is it just the same thing under a different name? It's just utter confusion, especially since many texts on special relativity start saying the ether is disposed of, and the next minute Einstein is bringing back a different version of the ether, so he hasn't completely got rid of it. So this is the confusion between Einstein as a young man in 1905 disposing of the ether, and Einstein in his later years seeming to bring it back again. This bit is about his objections to quantum theory. So imagine that we come to a bend of the road, to use a metaphor of Thomas Kern's. When we stand at the corner, we see clearly the road that we have passed, and also the road that is to come. The bend belongs to both parts. After you pass the corner, all we see is the new road and the bend that started it. We no longer see earlier part it completed. Einstein is the bend of the road that joins the 19th and 20th century's physics. So Einstein goes around the bend, which would mean nuts. He's gone nuts, and he's supposed to be joining 19th and 20th century physics with his relativity, and it's not that clear in this account how that is possible. You've got the ether which he discards as a young man, and then he's bringing it back as an old man, and it's supposed to be something different, a different type of ether. But Lorentz has been saying there's an ether, so how is it connected to any of this? Here is Kern's writing about Copernicus. To ask whether his Copernicus work is really ancient or modern is rather like asking whether the bend in an otherwise straight road belongs to the section of road that precedes the bend or to the portion that comes after it. From the bend, both sections of the road are visible and its continuity is apparent, but viewed from a point before the bend, the road seems to run straight to the bend and then to disappear. The bend seems the last point in a straight road, and viewed from a point in the next section after the bend, the road appears to begin at the bend from which it runs straight on. The bend belongs equally to both sections, or it belongs to neither. And that's Kern writing in the Copernican Revolution, page 182. So if you're trying to make Einstein out as the bend in the road between 19th and 20th century, it's not really clear at all how it's supposed to be, anything's supposed to be connected. But they want to portray him as this transitional figure. The image of Einstein as a transitional figure at the bend in the road seems to me to balance most effectively his connections with the times before and after him. The broader society, both popular and scientific, has found it hard to locate Einstein properly. Time magazine did well when it declared him Person of the Century in their last issue of the 20th century of December 31st, 1999. That seems fair. However, Einstein has also become a prescient figure whose hunches somehow anticipate every modern fad and excitement, Einstein was right has become a popular slogan among scientists, especially when they want to suggest that Einstein would endorse their latest discovery or conjecture. No, Einstein's supposed to be having hunchies, so it's not. If we're going on to the ether issue, how is this hunch of discarding the old ether and bringing in a new ether, and how is this hunch of this being on top of what Lorentz is talking about, Lorentz theory? It's none of this is explained. It's just a mess, really. I call it hunch, it's sort of like fogging it off. So this is a picture of him in his Time magazine, Person of the Century, and according to Norton, these are things you should know. The difference between the work of the young and the old Einstein, and that's the mess he's made with the ether. It's not clear. What's he talking about? He's talking about ether as a young Einstein, and he's talking about ether as the old Einstein. What's he talking about? What's going on? The relevant themes of 19th century physics and thought. How Einstein's work embodies these themes. That Einstein is one of the first of the new physicists of the 20th century, one of the last of the old tradition of the 19th century. And I think that is all just bluff. How does it connect to 19th century physics? Einstein's playing around with the ether. What's going on? It's not clear at all about any of this. So it's all a bluff. So how wonderful genius Einstein is. He's got hunchies, he's got these things, he's a bend in the road, and none of it makes any sense when you're trying to get down to the nitty gritty. What's he talking about? Why is he saying discard ether? Well, he's interpreted as saying discard ether in 1905. Why is he saying that? And then why is he bringing back this new version of ether? And textbooks are not going by what he says as an older man. Most of them just want to go by what he said as a young man, and they want to say there's no ether, and they don't bother to mention that there's a new ether. They don't bother to say what the older Einstein was saying. So it's complete and utter mess. It's a split. It's a split between old and young. Old and young Einstein caused a split. And so the way this person, John Norton, has written things, it's all bluffing it away here. The main issue is, how do you get away with what he says about ether? How does it connect? How does any of it connect? He's just completed utter confusion. There we go. It's a picture of John Norton. If we wait a bit, something might happen. Yeah, there you go, John Norton. So he's bluffed it. He's kind of bluffed it. Einstein. He's covered Einstein, the transition between the young and the old Einstein. What Einstein was saying about physics when he was young, and what Einstein was saying about physics when he was old. How does it connect? It's sort of bluffed. It doesn't really make that much sense. The relevant questions are Lorentz theory. How does what Einstein is saying connect to Lorentz theory? Lorentz theory is saying it's an ether, and Einstein initially is discarding it and then bringing it back again. It's just nonsense, really. It's not explained at all well. It's just bluffed off. Thank you.